So very good afternoon. Today we are learning the subject of electromagnetics. We will see here the topic of the wave polarization. On that we will see the few numerical on the subject of the electromagnetics. So in the electromagnetics here we will simplify the numerical on polarization. So wave polarization, what is the wave propagation? What is the wave polarization? In the theoretical part already we have discussed and studied that the content of the wave polarization. Today we are interested to simplify the numerical. So what is that numericals? We will see here. Keep ready your the pen, notebook and the calculus so that you can do yourself and you can simplify, you can cross verify the answers. Let's start. Note on the numerical. What is that? Numerical number 1, z is less than 0, z is less than 0, is a free space and when z is greater than 0, when z is greater than 0, the conductivity is equals to 10 raised to the power minus 4 Siemens per meter, comma, the epsilon is equals to 5 epsilon 0, epsilon is equals to 5 epsilon 0, comma, mu is equals to mu 0, mu is equals to mu 0, full stop. If frequency f is equals to 1.5 10 raised to the power 5, if frequency is equals to 1.5 into 10 raised to the power 5 hertz, and cos in bracket 2 pi into 10 raised to the power 5t, and cos in bracket 2 pi into 10 raised to the power 5t minus 10 raised to the power minus 3 pi z, bracket close, volt per meter. Volt per meter, full stop. Find here two things you need to find out: ER and HR. ER and HR. What is that? ER is nothing but again the reflection coefficient, you can say, at an electric field, or entire equation of the um, electric field of by considering the reflection coefficient or at the receiving point. Similarly, the HR is nothing but again the reflection coefficient or at a receiving point what will be the magnetic field. So what is given in this case? The given is that eta 2 is 104.559. Eta 2 is given as 104.552, 104.559, angle of 33.69 degree, angle of 33.69 degree. See here, the z value is given, that is a condition whether that z is above or the below of a 0. Conductivity is given, permeability and permittivity is given. Okay, even one condition is mentioned here, that is nothing but after a frequency the EI is equals to E0, means incidence electric field is equals to the electric field at a 0 or the free space. So E0 is treated as here the free space, electric field intensity at a free space, and this EI is nothing but electric field intensity at a what we can say the intensity. Okay, electric field at a intensity point, and here is the free space. So likewise one equation is given, that is in the form of the cos. Okay, and you need to calculate your the ER and the HR. If the eta 2 is given 104.559, angle of 33.69. How we can simplify this one, that is mentioned here. So what is that? How we can start? We can start for the electric field, the reflection coefficient. We know very well this formulas. The electric field, for the electric field, the reflection coefficient, for the electric field, the reflection coefficient is equals to tau r, is equals to tau r, is equals to What is the formula for the reflection coefficient in the electric field? That is a ratio of your the ER and the EI. That is the reflection and the incidence. Electric field at reflection as well as the electric field as incidence. Okay, how we can find? Directly we are not having this value of your the ER and the EI. We are not having this value ER and the EI, but we can find, simplify with the help of the intrinsic impedance. That is nothing but your the eta 1 and the eta 2. So what is that eta 1? For this free space, eta 1 is nothing but, already we have simplified many numericals on that. The intrinsic impedance constant value is nothing but 377. That is 120 pi is also you can take as the value of 377. So this is the eta 1. Similarly, what is the eta 2 is given? 104.559 angle of 33.69. Angle of 33.69. Similarly, the reflection coefficient after substituting this value, that is eta 2 minus eta 1. And what is eta 2? 104.55. So minus of 37. Similarly, plus of 37. So here we are interested Z1 minus Z2. That is nothing but this one is also in the polar. This one is also in the polar. Okay. So what we need to do, Z1 divided by Z2 angle of theta 1 minus theta 2, that you need to take here. Okay. So in this way you will get as after once you will get this directly. How it is possible to connect? We just take this minus term here, because 104 is lesser than the minus 377, and angle will be, there is here 0, here is also the angle will be 0. So in this way you can say upper numerator is also the polar form, denominator is also the polar form. Now z1 divided by z2 angle of theta 1 minus theta 2 you can take. Okay, that is a theta 1 minus theta 2, that is nothing but again the here is the 0, here is the 0. One case will come after this one. If you are going to subtract here, if you are going to add here, you will get in the numerator one polar form and in the denominator one polar form. Okay, so in this way you will get numerator one polar, denominator one polar, and that polar will be cut out and the angle will be subtracted. So in this way you will get the answer. Reflection coefficient is equals to 0.6325 angle of 161.56, angle of 161.56. Okay, now go for the second, that is nothing but reflection coefficient at the transmitting. Okay, reflection coefficient at a transmitting. This one is at a receiving it. So here will be your, we know very well the tau t plus tau t minus tau r is equals to 1, or in short you can say tau t is nothing but reflection coefficient at the transmitting point is equals to 1 plus tau r. So what is that 1 plus tau r? 1 will be as it is. What is the 2R? That is a 0.6325. Angle is mentioned 161.56. So now here these two are the magnitudes. Okay. So here the angle is again what we need to do directly. This is what we can say. This is the in the rectangular form, and this one is in the polar form. So what you need to do, first of all you need to convert this polar form into the rectangular, then you need to add the magnitude of that one, and this real term and the real term you need to add. Again, whenever you are going to add, after that you just convert that rectangular form into the polar form, then only it is possible to get this answer. That is nothing but 0.4472 angle of 26.56. So in short, what I mean to say, directly it's not at all possible. You need to convert that polar form into the rectangular form, then you need to add, and then you need to take the theta 1 minus theta 2, or depending upon that which thing you are getting, whether you are getting the plus or the minus. So in this way you will get the total. Similarly, what you need to write the standard equation for the ER, that is nothing but the electric field intensity at the reflection coefficient. So here the standard is nothing but whatever you will get, that is a magnitude form. Okay, so here that is nothing but, here the 2R, that is 0.6325 is E0. Cos of this term will be as it is here. What is that? CL. So EI is equals to E0. So what we are writing here, the ER is equals to E0, but is along with the E0, that is nothing but the EI, both are same. 0.6325 E0 cos of 2 pi 10 to the power is, this part is given, plus of, yeah, apart after this pi z, plus of how we got this 0.897 point. Yes, how we got this 0.779 0.897 pi, that is in the what we can say, the in the z direction. Okay, and you need to calculate, you need to substitute the value, that is omega t. Okay, 2 pi f. So you need to substitute the value, you will get this answer in the direction of az, that is the volt per meter. Similarly, hr is equals to, that is nothing but whatever you are getting that divided by 377, because hr is equals to the value of your the e divided by eta. The HR is nothing but the ER divided by eta. In short, you can say HR is equals to ER divided by eta. What is my ER? ER is nothing but this one, 0.6325 E0 cos of 2 pi 10 raised to power 5 t 10 raised to power minus 3 pi z plus 0. So and so, but in the y direction, because the electric field is in the x direction. So in this way you can get how we got this minus, just because of the opposite one, they are perpendicular to each other, that's why we are taking this minus. In this way you can magnitude will be divided, 0.6325 divided by 377, that will be your the 1.678 10 raised to the power minus 3. E0 will be as it is, cos of will be as it is, 2 pi 10 raised to the power 5t will be as it is, plus 10 raised to the power minus 3 pi z, and 0 points will be as it is in the ay direction and measured in the ampere per meter. Now go for the second numerical. Polystyrene has relative permittivity of 2.56. Polystyrene has relative permittivity of 2.56 if a wave is incident at an angle of, if a wave is incident at an angle of theta I is equals to 35 degree, theta I is equals to 35 degree from the air into the polystyrene, from the air into the polystyrene. Calculate the angle of, calculate the angle of transmission of theta t. Calculate the angle of transmission, and that is denoted by theta t. Angle of incidence is denoted by theta I, whereas angle of transmission is denoted by theta t. So in this way you can you just note down whatever the parameter is given, and what you need to calculate, that is nothing but the theta I. So what is mentioned here, the material is a polystyrene, you can say, and the relative permittivity is given, that is at 2.56. Here the two mediums are there that we need to take care, that is the air as well as the polystyrene. So here the permittivity and the permeability will be there, that is nothing but the epsilon 1 is equals to epsilon 0, mu 1 is equals to mu 0. Secondly is given for the other medium, that is nothing but the epsilon 2 is equals to 2.56, and of your that epsilon 0. How we got, see here, the polystyrene has a relative permittivity of 2.50. Okay, so second is nothing but 2.56 of your the first one. Similarly, mu 2 is equals to mu 0 will be as it is. Now come to the point how we can calculate the angle of transmission. The angle of transmission we can calculate as sine theta I divided by sine t. Sine theta I divided by sine theta t is equals to root of epsilon 2 divided by epsilon 1. Root of epsilon 2 divided by epsilon 1 is equals to root of 2.56 epsilon 0 divided by epsilon 0. Now come to the point, which thing will cut out on the both the numerator and denominator, only the epsilon is mentioned, so epsilon will cancel out, and your the 2.56 will be there. Root of 2.56 divided by 1, so that will be cancelled out. Here with the sine of 35 degrees mentioned. Now come to the point sine theta, which is in the root. Or you can calculate, so this sine theta I will become at one side, sine theta t will become at one side, and sine 35 root of 2.56 will be as it is. So in this way sine 35 degree will be your 0.573, 0.573, 0.573 573 divided by root of 2.56, nothing but 1.6. Now sin theta t is equals to 0.358. 0.358. Okay, all of you got this one. Sin theta t is equals to 0.358. Now last point, that is nothing but the angle at a particular transfer. Theta t is equals to what will happen, sin inverse of so that is nothing but 0.58 degree. 0.358 degree. So this sin inverse of 0.358 degree will become as your the 20.9 degree. 20.9 degree is nothing but your the theta t. Now come towards the third numerical, numerical number 3. Find the reflection coefficient and the transmission coefficient. Find the reflection coefficient and the transmission coefficient of an angle. Find the reflection coefficient and transmission coefficient of an angle of an reflection coefficient and the transmission coefficient of an electric field wave traveling in the air and incident normally on a boundary between the air and the dielectric is having a permeability is equals to mu 0, and dielectric having the permeability is equals to epsilon 0 and permittivity epsilon r is equals to 4.74. So all of you once again read this question, what is given here. So what is given here? Find the reflection coefficient and transmission coefficient of an electric field wave traveling in the air. Incidence normally boundary between the air and the dielectric having a permeability mu 0 and the permittivity epsilon 0 4.74. So what are the things you need to calculate? Reflection coefficient and the transmission coefficient. So reflection coefficient is denoted by 2r. Transmission coefficient is denoted by 2t. Already we have seen this formula. 2r is equals to eta 2 minus eta 1, whereas and the denominator is nothing but eta 2 plus eta 1. Second is nothing but your the transmission coefficient 2t, which is equals to 2 eta 2 divided by eta 2 plus eta 1. Now here, how we can calculate the eta 1 at a free space, that is a root of mu by epsilon. Here for the air you can say mu 0 mu r epsilon 0 mu 0 epsilon 0. These are the constant value and we know very well the values of that. Okay, if you are going to substitute the constant value, definitely 120 pi or the 377 will be the value. For the eta 2 you can get as root of mu 0 divided by epsilon 0 epsilon r. So mu 0 divided by what is my epsilon r? 4.74, because here the mu r is nothing but for the air, that is a 1. So mu r is a 1, mu r and mu 0 divided by epsilon 0 and the 4.74. So what will happen here? If you are going to substitute the value mu 0 and epsilon 0 is 4.74, so here will be 0.459 eta 1, because unknown parameter is nothing but you are the eta 1. Whatever you are getting, that is nothing but 0.49 that you can substitute, and unknown parameter is nothing but you are the eta 1. So in this way you can substitute the eta 1, because we have not calculated, even though we know very well the constant value. So eta 2 is nothing but 0.459 eta 1 minus of eta 1, again here the plus of eta 1. So 0.49 minus of 0.45 eta 1, the common will be over the eta 1. The 0.45 minus of 1 is 0.45 plus of 1. You can get an eta 1 will be cancelled out. So now so 0.59 eta 1. So now the tau r is equals to, substitute in the formula, so definitely you will get as here the minus 0.379. So here tau t, these are the two cases. See here the tau r and the tau t, the reflection coefficient and the transmission coefficient t and the r can be shown here. The tau t, is nothing but 2 eta 2 eta 1 plus eta 2, substitute the value 2 into 0.45 eta 1 here, again 0.45 plus 1 of eta 1. So likewise these two will be cancelled out and you will get as 0.621. 0.621. So in this way you can calculate the reflection coefficient tau r, you can calculate the transmission coefficient tau t, you can calculate the unknown parameter of eta 1 and the eta 2, you can substitute the eta 1 and eta 2 value in the tau r, likewise in the tau t. So you will get the answer. Go for the next numerical. What is that? Given that tau r is equals to minus 1 by 3, given that tau r is equals to minus 1 by 3, tau t is equals to 2 by 3, tau t is equals to 2 by 3. First off, find pi, pr, pt. Find pi, power of incidence, power of reflection and total power. Pi, pr and pt, power of incidence, power of reflection and the total power. Pi, pr and pt. So likewise what we need to do, two parameters are given, 2r and the 2t, and you need to find out the unknown powers. So that is nothing but denoted by the p. How we can find? First of all, start with the given parameters. That is nothing but tau r is equals to minus 1 by 3, tau t is equals to 2 by 3. What we need to calculate? Pi I is equals to unknown, pi r is equals to unknown, and pi t you need to calculate. So now here how we can calculate tau r? Tau r is nothing but er divided by ei, which is given directly, minus 1 by 3. So here what we can do, er is equals to tau r into the ei. So ei will be as it is, what is my tau r, that is minus 1 by 3. So here substitute the value of your the tau r directly, that is minus 1 by 3 in this formula, that is nothing but er divided by e. So in this way you can get ei divided by 3. Similarly tau t is nothing but et by ei, 2 by 3. So et is equals to 2 by 3 will be as it is, and ei will be at the side. Now what is my incidence of power is equals to 1 by t ei square divided by eta, 1 by 2 ei square divided by eta. So what is my 1 by 2 will be as it is, ei will be, what is substitute the value of ei? Where is my ei? What is my ei? Ei is nothing but er square. See it, squaring on both the sides if you're doing. So er is nothing but er square divided by eta 1. Substitute the value of 1 by 2 into eta 1. Okay, these 2 and this eta 1 will be as it is. Substitute the value of your the e square, er square. So what is my er square, which is I have got in the above equation, minus ei by 3. So here minus ei by 3 will be as it is, squaring term. In this way you will get as a, what we can say, the value will be 1 by 9 pi. 1 by 9 pi. Pi will be as it is, 1 by 2 of ei square divided by eta 1. Why you are going to substitute the value of er and other, you will get 1 by 9 into pi. 1 by 9 into pi. How we can get that pt? Pt will be 1 by 2 et, that is nothing but the total power will be the et square divided by eta 2. 1 by 2 will be outside. What is the et? That is a 2 by 3 ei will be whole square, and eta 2 will be outside. So in this way you can get as ei 1 by 2 and the 4 by 9, because the 2 square and the 3 square will be the 4 by 9, and ei square will be as it is. Okay, and how we got this eta 1 and the eta 2? Yes, eta 1 and eta 2. How you can get this eta 1? And just because of that the ET, okay, because eta 2 is equals to here is the eta 2, right? Here is the eta 2, and where is my eta 2? Eta 2 is here. So you can substitute the value of eta 2 is nothing but eta 1 by 2. So again that 2 will be go up, eta 1 will be cancel out, here eta 1 will be cancel out, this 2 will go in the numerator, and in this way you will get 8 by 9 pi. 8 by 9 pi. So 1 by 9 pi is reflected, 8 by 9 pi is transmitted. So transmitted power, reflected power, we have got the last numerical. What is this one? So what is given here? What is given here? Given two dielectric medium, given two dielectric mediums, of which medium is given. Determine the mu r epsilon 0 is equals to mu 0. Determine the reflection coefficient if the theta I is equals to 30 degree. Number one, perpendicular polarization. Number two, parallel polarization. It means that on a given parameter, that is a theta I, theta t, etc., you need to find out the reflection coefficient. You need to calculate the reflection coefficient in the perpendicular polarization as well as the parallel polarization. So, okay, what you need to find out? You need to find out the, what we can say, the polarization for the perpendicular. Okay, the reflection coefficient you can calculate easily. Perpendicular polarization and the parallel polarization, in the both the cases reflection coefficient you need to calculate. So what is my 2r? 2r is equals to, if I want to calculate perpendicular polarization, we remember 2r is equals to root of epsilon r1 cos of theta I minus epsilon root of epsilon r2 cos of theta t divided by root of epsilon r1 cos of theta I plus root of epsilon r2 cos of theta. So epsilon r is in terms of the theta is only becomes as 2r is equals to, what is my theta I? See here. This we can take a common, and the one of the root cos theta I is minus root of this epsilon 2 divided by epsilon 1. Epsilon 2 divided by, because epsilon is nothing but epsilon for the two medium 1 and 2. For the two medium 1 and you can take the ratio. So epsilon 2 divided by epsilon 1 sine square, because just these two cos will be converted, and sine square of theta I. Similarly, cos of theta I in the root of plus, see here the difference between minus and plus sine square theta of I. Substitute the value of cos of theta I, and that is a 30 degree. Sine of theta I, that is nothing but again the 30 degree. So in this way you can calculate reflection coefficient as minus 0.381. Now come towards by equating the equation sine theta I divided by sine theta t is equals to root of epsilon 2 divided by epsilon 1, which is the root of again the 4 epsilon 0 divided by epsilon 0. Epsilon 0 will be cancelled out. Root 4 will be the 2. And the last is nothing but sine theta
मैम
degree,
देखने दो ना.
sine theta degree, that is 30 degree, sine 30 degree divided by sine theta t is equals to 2. And so the sine theta t is equals to sine 30 degree divided by 2, that is a 1 by 4. You can substitute here the unknown parameter, that is a theta t, you can get as a 14.4. And if you are going to substitute the value here at the end, that is a uh, uh, you can get as a minus 0.381. Now last is nothing but the parallel polarization, that is a 2r reflection coefficient root of the epsilon 2 cos theta I minus of root of epsilon 1 cos theta t, root of epsilon 2 cos theta I, again the root of epsilon 1 cos of theta t. That we are converting into the standard form. Okay, and you can substitute the value of your the incidence, that is the permeability. You can substitute the angles 30 degree and 14.4 degree. In this way you will get as a 0.283. 0.283. 0.283. So in this way, I'm going to stop here. We have simplified 4 to 5 numerical on the wave polarization. On a wave polarization, we have simplified 4 to 5 numericals. So now in this way, I'm going to stop this meeting.